How about that? All right, we've got audio, we've got video. Stream is looking all right. I updated the firmware on my ATEM Mini Pro ISO. I had updated the software thinking that that would also update the firmware on the device, but it apparently doesn't, and I haven't done that in a year, so hoping that will improve things on the stream side. All right, I got chat open, got my terminal ready to go. I'm just going to go ahead and get started. All right, day 6, Guard Gallivant. The historians use their fancy device again, this time to whisk you all the way to the North Pole prototype suit manufacturing lab. In the year 1518, turns out that having direct access to history is very convenient for a group of historians. You still have to be careful of time paradoxes, so it will be important to avoid anyone from 1518 while the historians search for the chief. Unfortunately, a single guard is patrolling this part of the lab. Maybe you can work out where the guard will go ahead of time so the historians can search safely. You start by making a map, your puzzle input, of the situation. The map shows the current position of the guard with a hat to indicate the guard is currently facing up from the perspective of the map. Any obstructions, crates, alchemical reactors, etc. are shown as hash marks. Lab guards in 1518 follow a very strict patrol protocol which involves repeatedly following these steps. If there's something directly in front of you, you turn right 90 degrees. Otherwise, you take a step forward. Following the above protocol, the guard moves up several times until she reaches an obstacle, in this case a pile of failed suit prototypes. Because there is now an obstacle in front of the guard, she turns right before continuing straight in her new facing direction. Reaching another obstacle, a spool of several very long polymers, she turns right again and continues downward. This process continues for a while, but the guard eventually leaves the mapped area after walking past a tank of universal solvent. By predicting the guard's route, you can determine which positions the lab will be in, which positions in the lab will be in the patrol path, including the guard's starting position, the positions visited by the guard before leaving the area marked with an X. In this example, the guard will visit 41 distinct positions on your map. Predict the path of the guard. How many distinct positions will the guard visit before leaving the mapped area? Okay. Let's go ahead and get started. We've got, let's see, just prepare 6. We'll prepare day 6. And then this time I'm going to remember to add it to here. I'll probably automate that at some point, but for right now, that's it. And let's open up an Xcode. All right, so let's go into day 6 main. No, over here. So I've got test on the right, code on the left, struct day 6, enum day 6, static func part 1. This one is going to end up doing the grid parsing from before. That was day 4. So I think it's time that we bring the grid type out of here and the point type. Search neighbors for character. I suppose all of this stuff could be done. Now this one's looking for a sequence. This one's pretty specific to day 4's solution, but everything else is generic. I'm going to take all that out and we're going to add a new grid.swift. And then a lot of the stuff will need to become public. Same thing for the point type. And yeah, that needs to be public, and so does the adding. Okay. And cannot be used extension. Okay, yeah. That means all of these need to become public. Same thing here. Need a public initializer for grid now, which I can do right here. Yeah, so far the I'm getting 6 megabits on average for the stream. And I think it was bouncing between 3 and 4 before, and YouTube kept giving me warnings. And it wasn't my network speed. So hopefully this is better. Okay, so now that we've done that, I want to run the tests to make sure that we didn't break anything. And this will be important as we change code that is used by previous days. I don't want to copy and paste every time. It would be nice to be able to reuse stuff that we've created. That should be fine. This one is missing return, so let's do that. I forgot to make the initializer public. All right, so should be running all the tests. Nice. Okay. So in day 6, we're going to read this input and turn it into a grid of characters. So if we do basically exactly what we did in day 4, this input gets turned into a grid. So let's start with a private static func parse grid. Turns a grid of character. Now I can say let grid equals parse grid input, and we can print it out. And then in day 6 tests, let's create the struct day 6 tests. Input equals the input we got from before, which is this. All right. So in this case, I may want to not do it as characters because there's only 3 types. It's either empty, an obstruction or obstacle, and the guard. But also, so the guard is always facing up initially, so the guard has a direction. So I think the guard will, I mean, we can render the guard with whatever, either hat, a V, or angle brackets, depending on the direction. So I think initially the guard will probably always be facing up. I don't know. Let's take a look at the puzzle input. Yeah. So the guard is initially facing up. So when we parse, we could just care about that. All right, let's just make sure that we can actually print out the grid. We can. Okay, and then I think it was 41 was the, yep. So at this point, our test is wired up, ready to go. I can close that and focus on this code for a moment. So in not this code, the day 6 code. In here, we're going to create an enum for the different cells on our grid. And it's either going to be empty, which will be a dot. And so this will be character. Empty, it'll be an obstacle. Or it'll be the guard. And we'll use the hat to represent the initial position. But when we render the guard, if we're going to do like iterative rendering, we can decide to rotate it. Okay, so now instead of doing this, it's going to be a grid of cells. And this one, lines.map line and array line. This one needs to be line.map cell.init. That becomes optional. And I want to, let's do compact map. Okay, so now we should have an array of cells. If I run that test again, we now have a whole bunch of cells, but we've got empties, we've got obstacles. We can do custom string convertible here. So we end up printing out the grid correctly again. Okay, so as we parse this, we're going to have, I guess after we're done, we're going to be finding the position of the guard in the grid. So we're going to have an extension on grid where we can search for an item. And then search for some t. Let's call it find one. Gives you a t, and then, or sorry, you pass in for target, and this would return to you a point. yeah, so that would be for Y in rows, X in calls. If this is a target, then return point. I think it's fine if we want to fatal error just to, let's do where T equatable so that we know that we can find something in the grid and compare it. Another way to do this might be to have an iterator over all of the points and values. That might be a cool way to do this, because then you could use collections to find what you're looking for. At least this will tell me where the starting point is for the guard. So at this point we have a grid. We're going to say guard position is grid.find1 for guard. And then, let's see, including the guard starting position. So we're going to say visited equals, let's see, include which specifics. Yeah, so we're going to want a set here of points, because the guard can rewalk its path. Let's turn around and make this hashable, which implies equatable. Visited.insert guard position. Okay, so the thing I want to do now, I think what we'll probably do is have grid.swap. Or the alternative is to, I'm actually not sure. I don't want to like swap values over and over again, but if I have a way to have like a mutating func, which swaps in two elements in the grid. Subscript is get only. Let's fix that, because we can not SwiftUI grid. Come on. Is that subscript? How do I do that? Oh, duh. It's like a property. Set data, yeah. Yx equals new value. Data is a let, which we are now going to make a var. And then same thing here for point. Point.y, point.x. So that will let me figure out like what is the direction that we're going to be pointing. Did I already have a direction in here? I don't think so. We do this all the time, so let's just add an enum, public enum direction. Up, down, left, right. Okay, so now we've got our guard position and our direction is up. So I want to continue while the guard position is inside of the grid. So we'll say while grid.isInside guard position. Then we're going to move the guard. We could probably, because these are, let's do offset as a point so that I can do, oh, check it out. I already have those. Amazing. So then I can add them to my guard dir. So I'm going to say the next position is going to be the guard position plus the direction. Let's just call this dir. Dir.offset. That needs to be public. I also want these to be, oh, actually, they should print fine if I want to print them. Okay, let next position. Now I want to check to see if the grid at that next position is equal to an obstacle. Then what we're going to do is change dir to turn right. And then we can do a mutating func turn right. I don't know if I want this mutating. We could just say turn right like that. That will return a direction. If we're up, we go to the right. If we're right, we go down. If we're down, we go left. If we're left, we go up. Okay. So we're going to say dir equals dir.turn right. Direction has no member up. What are you talking about? Public enum. Case up, down, left, right. Ah, I'm missing the switch there. Okay. Okay, so then we turn right, and then we'll just continue. If it's not an obstacle, then we're going to say guard position equals next position, and then we just keep going. However, here when we do this, we're going to say visited dot insert guard position, and we could probably just do that here. Yeah, okay. That's going to return the visited.count. And if we want to print out every step of the way what happened, we can take our grid. I guess I don't necessarily need to change anything about the grid unless I want to print it out every time. So what I'm going to end up doing here is saying that the let's actually add one more case here. Visited. Oh wait, no, that'll ruin our algorithm. Because we're checking to see... No, we're only checking to see if it's an obstacle. It might screw up part 2. I have no idea what they're going to throw at us. Like maybe the guard is actually a snake with a tail and it can't hit itself. Or maybe there are 2 guards. I don't know. But if I said visited equals X here, then what I would do is set grid at this guard position, and it doesn't need to do that. I can just do that. Equals visited. and then grid at the next position equals guard. All right, let's rerun the test and see if that works. Index out of range. Okay, we definitely need to check if grid.is inside next position and grid at that next position is an obstacle. Yeah, we can't do that. If the next one is inside, then we break. Kind of sucks because we are doing this here. I wonder if we just put a do. If I did while true, we do this, and then if the next position is not inside, let's do a guard. Grid.is inside next position. Else break. All right, test succeeded. Let's grab our puzzle input. And we will run it. Let's grab just this section here. Day 6, part 1. The stream is going way better. Yeah, the data rate is considerably better, almost twice as good as last time, and the delay isn't quite as bad. All right, so we got 5,030. Continue to part 2. All right. I'm going to one thing about starting so early is there's just a whole bunch of people that aren't awake yet. All right, while the historians begin working around the guards' patrol route, you borrow their fancy device and step outside the lab from the safety of the supply closet. You time travel for the last 3 months and record the nightly status of the lab's guard posts on the walls of the closet. Returning after what seems like only a few seconds to the historians, they explain that the guards' patrol area is simply too large for them to safely search the lab without getting caught. Fortunately, they're pretty sure adding a single new obstruction won't cause a time paradox. They would like to place the new obstruction in such a way that the guard will get stuck in a loop, making the rest of the lab safe to search. To have the lowest chance of creating a time paradox, historians would like to know all of the possible positions for such an obstruction. The new obstruction can't be placed at the guard's starting position. The guard is there and would notice. In the above example, there are 6 different positions where a new obstruction would cause a guard to get stuck in a loop. The diagrams of these 6 situations use O to mark the new obstruction, pipe to show a position where the guard moves up and down, and left to right, and plus to show a position where the guard moves both up, down, and left to right. Option 1, put a printing press next to the guard's starting position. Okay. Option 2, put a stack of failed suit prototypes in the bottom right quadrant. Option 3, okay. Option 5, put the alchemical retro encabulator a bit to the right instead. Okay. It doesn't really matter what you choose to use as an obstacle so long as you and the historians can put it into position without the guard noticing. The important thing is having enough options. You can find one that minimizes time paradoxes, and in this example there are 6 different positions you could choose. How many different positions could you choose for this obstruction? Okay. Yeah, this one's going to be tricky. I guess that if while we're walking or simulating the path, it would need to be lined up with another one. It needs to be one that the guard will hit, because there's no guarantee that it's going to hit every obstacle. So there's one approach that I'm thinking of that could be like while say you're walking to the left. Let me go back to the. Let's say I'm here and walking to the left, and I notice that in this position I've already visited. Then I know if I enter that one, going the same direction I was going, I'm going to hit something from before. So ignoring this as a... If that wasn't an obstacle, so I would have walked straight off. I want to, instead, I would notice that, oh, if I go up, I'm going to hit this one, so let me insert one here so that I can go up. That seems kind of tricky to implement correctly. Another option would be to take all the obstacles and group them by their column and row, because they all kind of have this weird pattern. So if I were to yeah, this seems hard. If I were to just say, starting with any obstacle, I would have to also know the direction they're coming from. So I would need to know which obstacles were hit at all. And from those, so I basically run part 1 and mark which obstacles were hit. And then from the end, what direction they were hit from. Let me draw something. Hit the wrong button. And killed my music. Nice. All right. Just need to bring chat back. All right. Okay. Wow, that's bright. Okay, so let's say I've hit, let's say I've hit this one going this direction. Brush tool. Okay. So I hit this one going this direction. What I need to do is search for some like each cell going this way to see if there is an obstacle on that side. If I find one, then I'd be looking here. I would be looking down for an obstacle. And then I would need to put an obstacle kind of right here. But the thing is if this one wasn't here, then what I would be doing is I'd be looking, every time I turn, I'd be looking down to see if there's an obstacle down. And if so, I can put an obstacle right in front of that path to force him to hit it. But there's no guarantee in that situation that once he hits the obstacle here, that he doesn't like continue on here and exit this loop. So I need to find loops that are missing just one element. So another way to think about it would be, let's ignore this little like off by 1 each time, just so we can think about it. If I saw this, I would match that. If I saw this, I would match it also. Right? Because then you could infer what the other one was. So we're looking for an L shape of matching obstacles of the ones that the guard hit during the simulation the first time. So I suppose as the guard goes, we will, as soon as we hit an obstacle, we're going to pause there and just sort of simulate. Does this look like one of these L shapes? And if it does, then we need to find the missing coordinate and add it. I think that makes sense. It's always going to be an L shape like this. There's only, if you have 4 and remove 1, it's always going to look like this. Okay, so in this scenario, I hit this one. Let's call this one A. Let's say B is not there. Then I'm just going to skip right over. So this scenario would be this one, and this one. So let's say A, and let's say B is not there. C and D are. So I go over and I realize, nope, this isn't an L shape. It's like going clockwise. So we'll just continue. Oh wait, no, that's not going to work because I would have to know if there is an obstacle down. I was thinking I would catch this case like once I was going down and hitting this one, but no, I have to. This will change their entire path. So if I walk to the right looking for something going downward, and I find this one, then I can try to insert an obstacle here. Yeah, I suppose I could do that because I don't even have to try to do that. I can just say, okay, starting in this position, look all the way down. There's nothing there. again here, there's nothing there. Again here, there's nothing there. Again here. Oh, it finds something. Now let me look to the left and see if I can find anything there. And if going left brings me back to my starting point, then I know that I'm here. I suppose another way to think about this would be if you arrive at a point, in order for this to be a match, there has to be one here or here. Or here. There has to be... No. Actually, sorry. Because we always turn right. Yeah, if I arrive at a match... I'm sorry, an obstacle. There has to be an obstacle to the right or down for this to even be a candidate. If I found one of those two things, if I found one of those two things, then what am I missing here? Option tab. There we go. Oh, it got rid of it. Oh, that's no fun. I'm just going to draw like this. All right, so I hit an obstacle. I'm going this way. Is this a candidate for a loop? Either there has to be something here to the right, or there has to be something down here. If either of those are true, then I can do that sort of searching logic. I mean, I don't need to search this way if I know there's an obstacle to the right. But I can't even bother doing that if there's nothing here and there's nothing here. Because then I would have to insert 2 to make a loop. I think that this makes sense. I'm just trying to like poke holes in it or see how am I going to know. So I'm going to call this a candidate if one of those two things are present. If it's a candidate and there's nothing to the right, then I need to search. So searching to the right is going to involve taking a step and looking this way. Taking a step, looking this way. I'm going to keep doing that. And at some point, say that there's an obstacle here. As I look, then I know that I need to insert the obstacle here to complete the loop. The other approach is as I hit an item, if I know that there's one here, then this is a candidate if either this one or this one is present. Yeah, this is a little strange because now I guess when I'm running this situation, if I hit this and I look to the right and there's one, then I need to look down to see if there's one here or one here. And if so, then that's a candidate. I don't know why it keeps erasing my drawings. That's really annoying. Yeah, I don't want to do that. I also want to prevent that splash. There's a lot of options for this thing. This app is Screen Brush, by the way. It's really nice. Splash on click. I just want to draw a dot. Okay. So I think that algorithm kind of makes sense. Now I need to figure out what we need to do to build it. So I think I want to have a search for target. T direction. I'm going to say search. This search is probably, let's call it look. Look from position point for target T in a given direction. And then that's going to return an optional T. No, an optional point. So if it found it. And this actually is pretty nice because we can say var next equals position plus the direction offset, which is what we wanted. If we're inside, well, while we're inside, if that's the target, we're going to return it. Otherwise, we're going to keep moving. Otherwise, and at the very end, we return nil. Okay, so this is what we will use to see if there is a there's an obstacle. So let's do static func part 2. Input string, turns a string. It's going to be similar here. I don't know if I need to. I feel like I need to run this simulation. It's similar to part 1, but then if it's an obstacle, yeah, so here's where we need to stop and look for a loop. The thing that really sucks about this is I've covered the case where you are going this direction, you hit an obstacle. We look over here for an obstacle. If there's an obstacle here, then we know exactly where to put this one. We've covered that case. We've also covered the case where remove your drawings by control. Okay. If I have this situation, then I'm fine because I can say, oh, I came in the direction, there's an obstacle behind me, so now I know if there's also one here that I can insert one here. So I've covered those cases. What I have not covered is this situation where there's already a loop, but I'm never going to hit it. So I think that if I'm coming from a block, then I need to constantly be looking to my right for a potential loop. Because if there is an item here, oh well, shift does that. If there's an item here, then I'm going to need to insert a block so that I can go that way. But I only need to do that if there's one behind me. Man. All right. Okay. I'm going to say let block behind equals grid.look from our guard position. We're looking for an obstacle, and the direction is going to be my direction dot mirror or something. Let's make that function. Direction. Yep, we get the opposite direction. So we're going to look from the guard position for an obstacle in the direction we're facing. Okay, if there is a block behind and there's not a block in front, then I need to be searching to the right every step. I feel like I'm going to need these positions, but so I think what we're going to end up doing here is every step of the way, as we start in a position, we're going to be inspecting, are we in a loop? Are we in a potential loop? So that's going to be all of this stuff. If not, we're going to move to the next position. Okay, so we want to check then if is there a block to the right of the one ahead. So that's going to be grid.look from the block behind point. I'm going to call that ahead. If let ahead equals block ahead. Is there a block to the right of the one ahead? We're going to start from ahead for obstacle, and we're going to be looking right. And this would be the top right one that we're looking for. If there's not, we need to look to see if there's a block behind us. We can insert one to the top right. So if our loops look like A, B, C, and D, let's give ourselves some space. Okay, so if we're here, we're looking to see if there's a block behind and ahead. Oh wait, this is to the right of the one ahead, which is dir.turnRight. Yeah, I can't just use right because this whole thing is going to be transposed based on the direction we're looking at. Okay, if there's a block behind or block ahead. Okay, if there's a block ahead, then we're going to look to the right of the one ahead. If there is one, then we need to search for C or D. If there's a block behind, so that means we've looked for, there's no B, but there is a D. So now we need to see if there's a C. Okay, if there's an A. Top right is a weird name, but I'm going to just call it B because I have the labels up here. We'll rename all of these actually. This is going to be D. This one's going to be A. If let A, then we're going to be looking for B. If there's a B, we need to search for C or D. So C is going to be grid.look from B for obstacle on dir.turnRight.turnRight. Else, if let D equals grid.look from A. No, we already have a D, don't we? Else, if let D, we can insert C. All right. Is there a block to the right of the one ahead? We're looking for B. If we did not find B, then we're looking for a block behind so that we can also search for C. think that I could just do let C equals grid.look to the right grid.look from point D for an obstacle turning right. Yeah. We can insert C. Oh man, this one's tough. So this all relies on us being able to see A first. If we can't see A, then I'm gonna have to step through each one and pretend there's an A and see if this works. But if I pretend there's an A, then the rest have to be there. This is tricky. Let's I'm gonna say potential block is a set of points. Potential blocks. All right, so I'm gonna go ahead and we can insert D. So this is gonna be potential blocks dot insert. We don't actually want to insert it because that would make this loop that we're in be infinite. All right, potential blocks dot insert. And now we need to figure out what point we want to do. So we're grabbing D, so the X position is going to be our guard's X position. And our Y position is going to be C's Y position. -1. Because I guess I don't need to paste those in. Okay, because if I hit this obstacle, it actually ends up looking like this. And then B is here. No, B is here. So if I hit A, then I go right to hit B, then I hit C, then I hit D. Okay. So that means that these are wrong, actually. So A is correct, D is correct. But then when I look for, I need to look from A plus point dot down. I need to go 1 down from A and look to the right. Yeah. So if we found B, then we need to look for C from B, except 1 to the left of B. These values aren't going to work. This only works for the values that are up. So I need it to be based on the direction. Direction.mirror.offset here. Okay. I'm going to have to do these on multiple lines. This one is going to be this is going to be the opposite of the direction we're going in. So we just walk back one and then offset. I wonder if that's going to be the same for each of these. So if I do turn right dot turn right, that would be going down. So would mirror though. Yeah, I need to go, from one before the obstacle. In the direction that I would be going in. So this is going to be my new direction that I'd be looking in. So this one would be plus dir.turnright.mirror.offset. Yikes. Okay. Also, I just realized I can't do -1 here either, because this has to be based on that direction that we're looking. Because if this whole thing is transposed, then we're going to be adding or removing to X or Y. So this one, this is going to be guard position. Yeah, I think what I need to do is say let new obstacle is equal to the guard's direction, the guard's position rather, plus this dot mirror dot offset. Which in this case, because when we turn right, that's going to be the same as going backwards. Then we mirror it and get the offset. Wait, why do we want to mirror it here? Oh, also C is not in here. That is going to be yikes. Okay, inserting D means that we're going to be we're going to take one component of the guard position, one component of C, and then offset it by 1. But I don't know if it's X or Y. That's the problem, because this whole thing needs to be transposed. I wonder if I could. So what I'm trying to avoid is, oh, if I'm going right, then I need to check for B first, then C, then D, then A, because we already have all of this logic. All right, let me just double check this logic. Grid.look from A, we're going up, so we'll mirror the offset will be here. We're going to look from here, and we're going to turn right, which is going to go this way. Then we're going to be looking at dir.turnRight.mirror.offset, which would take us here. And then we're going to be looking at turn right, which is down, yes. And we'll search for C. So the weird part is that I need to know were we going horizontal or vertical in order to know which position of the guard position we're going to take and which position of C we're going to take. It is times like this that I'm like, okay, well, we could slog through this and probably get the right answer. But I always have this like nagging question of like, well, what if I just missed something way simpler? Which is certainly possible. This is one of the reasons why I like working with other people and pairing. It's just sometimes you miss something that that is obvious. But I don't necessarily care. Like, it doesn't have to be the best solution. I just don't want to overcomplicate things if there's something easier. So the problem that I'm running into now is I need some way of knowing where D is. Because we just found C, so we hit A, we look to the right, we hit B. From here we look down, we hit C. And so from the position right before C, I was just thinking that I wonder if like transposing the whole grid makes this easier so that I don't have to do this component by component. Okay, so if we can insert D, we're going to take C and back it off by 1. Which is going to be that same position before C is here. And then I need to take either the X component or the Y component of this, depending on if we're vertical or horizontal. So let's say potential block is the guard position. Let's do it like this: point dot guard position dot X and position before C dot Y. And then if we're vertical, let's just make this a let with a point. If the direction is vertical, we're going to do potential block is this. Otherwise, we're going to do the opposite. We're going to take the position before c.x and the guards y. Okay, let's go grab another public function, or public var is vertical. Up and down, let's do the same thing for horizontal. Okay. Potential block gets inserted here. Okay, if we did not find C, then we did find D, then we can insert C here. So it needs to be one before B and one before D. And it doesn't matter. Also, this should be the A position, really, not the guard position. I think that is probably more accurate. Is that right? No, it's not right. We need the position before A. Yikes. In the horizontal dimension. Let's see. Position before A is going to be the direction.turnright.offset. No, mirror.offset. That's the position before A. Yeah, because I need to get D to be, all of these move over by 1. That's what I'm looking for. So if I started here, I go up, I hit A, I look right, I hit B, I go down, I hit C. So if we found C, then we can insert D, and we get the position before C, which is here, and the position before A, which is here, and we take those two components, whether they're X or Y. So this one can be transposed. If we go to point, and I say, public var transpose gives me a new point with y and x swapped. So if we can go back to just doing this inline. If it's vertical, then we're going to do potential block equals potential block dot transpose. Okay, I think that's correct. This thing is going to be a bitch to debug. Just because I feel like I have to hold all this stuff in my head. All right, if we can insert D, because we found D, we can insert C here. So it's going to be basically the same kind of idea. We need the position before D. No, we need the position after D. The position after D, we will not mirror. This needs to be D plus, and this needs to be A plus. I didn't do that here. Okay, let's just double check this one. Position D is going to be D plus. So we're just assuming that we are vertical at the moment, pointing upward. So we turn right and then turn right. We're going to be pointing down. So we're going to add 1 here. That's where we want to be. And then position before B. This needs to be before B. We're going to turn right. So we're faced right. Then we mirror, we go to the left, and offset gives us 1 to the left of B. Perfect. So this needs to be position before B, position after D. Okay, if we found D and C, then we can insert B. And this one can't be look from D, but it needs to be D after. Turn right dot offset. This is so confusing. I want to make sure that I don't have any that I'm looking without doing the offset. Okay. Okay, so at this point we found C and D. We can insert B using A and C. So it's going to be similar to this, but with A and C. So this will be position before A is A dot dir turn right once and mirror. Is that... No, this is just dir.mirror.offset. Position before A, we don't turn at all. Position before B, we're looking for B, so this needs to be before C. So that needs one more turn right, I believe. Position before C. Yeah. Let's swap those and those. Wow. Okay, so so far I think this will handle all of the cases except for the one where we don't have an A. If we don't have an A, then we just need to look to the right. Look to the right every step. I'm going to be moving in that direction, so I just need to look to the right where I am. So else if let B equals, because we don't have a B at the moment, that's going to be grid.look from the guard position. From guard position, looking for an obstacle in the direction dir.turn right. So this is handling the case, just again, this case where this one doesn't exist. So we're looking every step through the loop. And because we're already stepping through, if there's nothing in front of us, then eventually we will reach the point where we're here and we see this one. So if we see this one, D also has to exist, and C has to exist. So let's so else if let, I'm going to say if let D, let B is this, and then let C is, we're going to start from B, we need to go one before B, so this is going to be turn right dot mirror dot offset. In the direction turn right, which will go down. Yeah. Okay, so if we have D, B, and C, then we can insert A, which again is going to be the similar steps. We need the position before B and the position before D. No, we just need D, I think. This is so confusing. If we're inserting A, then I need the position before D, but this is really the position after D. And the position before B. So this is going to be the position after D, is going to be D plus turn right once. The position before B is going to be B plus dir.turnright.mirror.offset. I think I made a mistake on all of these. Let's see. Because if we're vertical, I don't want to just swap these. I want to take the opposite dimension. Yeah, this is going to put me in a different part of the grid, which I don't want if we start using x's for y's. So all of these transposes are wrong. So I need to do else here. We're going to do let potential block as a block. I think that we can, I don't know what to call this, but I think that we could probably add something on point where it's going to say we're going to combine 2 points, but which component do we take? So if we say, let's say we say public static func combine, and we've got an A and a B point. And then which one do we take from each is going to be based on the direction. And this sort of doesn't make sense generally. It only kind of makes sense for what we're doing. Right? So if I say if the direction is vertical, then we're going to return, sorry, I don't know why I said bool there. That's point. We're going to return a.x and b.y. Otherwise, we're going to return b.x and a.y. I don't know what you call this. Combine is kind of a strange name for this. the thing that we're trying to do is say that I take this one and this one. I either need to do, I'm like getting a corner point, if that makes sense. Yeah. So why is it based on the direction? That's the kind of weird part. Yeah, I don't have a good name for this. I'm just going to call it corner point because I don't have a better name, and I think that this doesn't belong here either. So let's move this into here as an extension. Okay, now this needs to be, sorry, the first potential block is going to be let potential block. This is going to be a point.corner point between position before A and position before B, before C, and the direction is dir. So if we're at A and C and we're going vertical, if we have A and C, then we're looking for B. So I need this to take the Y position of A and the X position of C. So I have these backwards on the corner point. I think I could probably just change this to is horizontal. Okay. And now I don't need all of these. Same thing here. This will be let potential block point.corner point position before B and position after D, and direction is dir. And then finally this one, let corner point okay, we didn't use C. So we can insert A. We don't care about C, actually. We just need to see if there is one. Okay. And if there's not, then we just keep on marching. We're going to be inserting these potential blocks every time, and at the end, we're going to print out potential blocks is potential blocks, and then we'll return potential blocks.count. Okay. Our test, we expect, oh yeah, we didn't write the part 2 test. Part 2, this one, I think there was 6. There are 6 different positions you could choose. Let's try that. Test failed. Part 2 failed. It got 41 because I'm running part 1. This time I got 10. Okay, so I got too many. Let's take a look at the input here. Option 1, put a printing press next to the guard's starting position. Okay, so that would be X 0, 1, 2, 3, Y 0, 1, 2, 3, 4, 5, 6. So 3, 6. Did we get that one? We got 3, 6. Option 2, put a stack of failed suit prototypes in the bottom right quadrant of the mapped area. So that is X 0, 1, 2, 3, 4, 5, 6, and Y 0, 1, 2, 3, 4, 5, no. 0, 1, 2, 3, 4, 5, 6, 7. So 6, 7. I got. Option 3, put a crate of chimney squeeze prototype fabric next to the standing desk in the bottom right quadrant. Okay, that is X 0, 1, 2, 3, 4, 5, 6, 7. And Y 7. So this would be 7 and 7, which I also got here. 4 would be X1, Y8. We got. This would be X0, 1, 2, 3, Y8. I did not get that one. I don't know if it would be helpful to like print out these directions. I certainly don't have time to do that today. The diagrams of these 6 situations use O to mark the new obstruction, pipe to show a position where the guard moves up, down, dash to show a position where the guard moves left, right, and plus to show a position where the guard moves both. I mean, I suppose I could print each one of these out and see. Let's, in part 2, I think what I'm going to do is we're not going to insert the visited step. I don't care about that, but I do think that this could be, if I go back here, I could say case horizontal travel. Let's call this travel, and then we'll call this another enum for travel dir. And then this will be horizontal is dash case vertical equals pipe case both equals plus. So case travel, oh, I can't do this. I can't do it because of the associated value. Well, maybe I can. Maybe I... It's going to ruin my compact map, but that's maybe okay. Travelder. We can no longer be a character here. Yeah, I don't like this. If I take this and just move them down here and do travel horizontal, vertical, or both. No, what did I just do? Yeah. I think there's a way to go uppercase, but I can't remember what it is. Okay. That's fine. All right. I've got basically 15-20 minutes before I need to wrap it up, so I'm going to try to get some better intuition based on printing what's going on to see which one of these is not correct. So if I go down to where we're traveling, we're going to stop here. So the next position is an obstacle. So the position I'm in right now is going to be the grid for this position is going to be at the position the guard is going to be a travel both. Otherwise, we're going to check to see if the direction that we're in is horizontal, then this is going to be travel horizontal or travel vertical. Okay. What I would like to do now what I think I'd like to do is somehow if we just got a potential block, I want to print out everything. And the potential block would be also on here. Equals O. 0 or O? I guess O. I'm going to do this just manually each time through, every time we're creating a potential block. And I want to see what's happening each step of the way. I guess I can just step through it. Well, no, I need to know if I just inserted a potential block, that's when I want to print out everything, and I actually want to erase all the travel directions at that point. All right, found potential block equals false. Let's do it this way instead. Potential block is a point. So then here I can do that. and then we can move this out of all of this. If let potential block, we do this. And also I want to print, then wipe travel marks. This clears up a little bit. Okay. Now we would say we don't have a map function for grid. I would need an iterator for y equals grid, for y in 0 dot dot less than grid dot rows, for x in 0 dot dot less than grid dot columns. If it's a travel, horizontal, vertical, or grid, XY, let's cell equals grid XY. If cell is equal to travel both or travel vertical or travel horizontal, then we're going to set it to empty. And then we're also going to set the grid potential block to empty as well, because I don't want to keep those around. I just want to print it. Okay. So now if I run our test, I'm going to get each one through, and then we can sort of examine what the grid looked like. Oh yeah, we haven't actually traveled. We just did the looking. So, I don't know if you can see that, but I'll make myself a little smaller. Yeah, you can see it. That's fine. So, that's the first one. The second one, let's go again. I don't want to do that. I just want to continue. All right, continue until we get here. Step over. And now we got down and to the left. So does that make sense? We go here, we go here, we go here. Yeah, down and to the left. Is that one? Yeah, I mean, we have one of these is a false positive. I don't see that one in their list though. Maybe I'm missing something. Can't be placed at the guard's starting position. The guard is there and would notice. In the example above, there's 6 different positions. The diagram. So it's almost like I would need to like run through the grid in order to print out these paths. Also, that's backwards. It took a step upward. That's what happened. It stayed there for the second one because we didn't find a potential block. That's what happened. Okay. The travel marks are wrong. If it's horizontal, then travel horizontal. I feel like that should have worked. All right, we're gonna run the test one more time. And I'm just gonna step through. So every time through, if I want to, I can print the grid. If I do E print grid, we'll see where we are. Okay, so it'll find an A up here. It will not find a D. So D is nil. So that's correct. So there's an A, and it's looking for a B, and it found one. So it found this one. And one before that should find a C. So we should step in here. And we can insert a C at that correct position. So potential block becomes 3, 6, 0, 1, 2, 3, 6. Yep. So that's correct. So we got our potential block, we insert it, we print it, we print the grid so we can see where the block is. And then I'm going to skip down to here to reset the potential block. Then we move to the next position. If the next position is an obstacle, this comment is wrong now. It's not an obstacle, so then our direction here, our direction is up. Yeah, that's wrong. I think I just totally, goodness, down, sorry, left or right. Okay, I hope that, well, not that I hope, but that could have caused my algorithm to be just wrong. So we run this again. I still got 10. I don't want to run. I want to run the tests. And I don't want to run all the tests. I just want to run day 6 tests. Oh, this is wrong. What happened here? This is the first one it found. This is completely wrong. So what happened? It found an A. I thought we just stepped through this. The horizontal direction was used there, and the corner point was used there. So did I get this one wrong then? Because I think I'm getting the wrong corner point. If it's horizontal, this needs to be as vertical. If we're looking up and we want to get the corner point between A and B, 2 points, I'm going to take A's X. No, that's fine. I want to take A's Y. Yeah, so this is correct. So I think I have Maybe A and B are backwards here. Because it does look like a reflected point. Like this one should be down here somewhere. That's, well, I don't know. Let's just step through. All right, so A is x4. Y0, that's correct. D is nil. So now we're looking to the right. And we find B at uh, 9,1. We find C at 8,7. The position before A should be this one. So it should be x4, y1. That's wrong. It's doing this one. Dir is up. We need to just mirror. Let me make sure this is correct. Up is down, down is up, left is right, right is left. Okay. Up to right, right to down to left, left to up. Okay, those are correct. All right, we gotta run it again. Okay, so we know A and D are correct. B is correct, C is correct. The position before A is 4 and 1 now. The position before C is 8 and 6. So if I print the grid, 0, so that's going to be here, and 0, 1, 2, 3, 4, 5, 6, perfect. Potential block is 8 and 1. Yeah, sorry, this was, something happened. I skipped over it. A is correct. B is correct. Is C correct? 8 and 7. That's this one. 8 is here. 9, 8, 0, 1, 2, 3, 4, 5, 6, 7. This one's wrong. No. Sorry, C is correct. If I was getting the position before. Okay, the position before A is 4, 1, which is here. That's correct. The position before C should be this one. So it should be 8, 6. Yeah. Okay, so getting the corner point between the two of those, because we're looking for D. We should be getting the lower one. It's getting the upper one, and that's not what we want. Yeah, so this one is weird because if I step into that, we get into corner point and we've got A, which is 4, 1, which is our A. The B here is our C point. And our direction is up, so it's vertical. So we should be getting B's X value. Whoa, that is wrong. I wonder if horizontal and vertical isn't what we want here. Because I can flip these around, but I'm wondering if that's correct. Let me just go back to this, because I had a bug with that earlier and I was getting the right answer, but I was also getting too many. But that calculation would just be printing out a location that I've already found. So I still have some false positives. But in this case, we should be able to go down to where we computed our potential block. Yeah, we'll print our grid. And we found it. It put it right on top of the guard location, which is wrong. This one was A and C. Oh, yeah. Okay. Yeah, I have two problems. I have like position before A really needs to be positioned to the left of A to insert that into the proper location. So let's call this left of A. That's going to be turn right dot mirror dot offset. Because I want the position before A, meaning down, when I'm need to look to the right. But when I'm computing where D should go, it needs to be one to the left of A. Let's just continue, print the grid. That is still wrong. Search for D. Oh, this was... Where did I do left of A? This is... We can insert B. This one is wrong. I meant to do this one. Left of A. dir.turnright.mirror.offset. I suppose I could have it turn left, but that's fine. Okay, now we got the correct one for the first one. Then for the second one, we got it's the same one. Oh yeah, it's gonna be inserting the same one over and over again for a while. I guess I should do something like, if the potential block is here and not potential blocks contains that block. That one. Okay, got that one. We continue. Just going to continue until I find the next one, then print it. That's totally wrong. All right, so this is a good stopping point because I now know that I have a problem with I now know I have a problem with the second match in the list, which is incorrect. But I'm out of time for today, so Samuel has joined just in time. All right. Yeah, this one was tricky. I spent far too much time on it. I'm not sure if I will finish this one or if I'll move on to day 7 tomorrow, but we'll see. But thanks for joining anyway, and I will see you again tomorrow.